Alright, question 5 says to solve each equation by rewriting it as a logarithmic equation first. And part A says 10 to the x is equal to 2. And if you recall, this is part A of the first question on the worksheet, so we've already done this one. Now to convert to the log statement, well, the exponent here is x, so that's going to equal our logarithm. And since this is a base 10 logarithm, I don't have to write in the subscript there, and so I'm just taking the log of 2. Okay, so now let's go ahead and use our calculator as we go. Oops, sorry, pull that up again. And we've already done this one, and we recall it's about 0.301-ish, and I'll just go ahead and say round to the nearest thousandth. It doesn't specify in the problem how many decimal places to round to, so we'll call it good there. All right. How about B? Well, it's pretty much the same, just a different right-hand side. And now we're using the letter t instead of x, so we get that t is equal to log of 3.2. So then again, we can go ahead and put in log 3.2 in the calculator. We get 0.505 to the nearest thousandth. All right, not too bad. Now for C, notice here the exponent is not just y, it's 2y. So converting to the log statement, this is going to say that 2y, the exponent, is equal to the logarithm, and again it's a log base 10, so I don't have to write that in, of 2019. But we have now another step, right? I need to know what y is on its own. So now I'm going to divide both sides by 2. And that's going to give us that y is equal to log 2019 all divided by 2. And then I'll go ahead and use the calculator to approximate that. And I'll just put it in exactly as it looks right there. So log 2019 divided by 2. And we get about 1.653 if we round to the nearest thousandth. All right, so it's at 1.653. All right, great. For D, we got 10 to the negative r is equal to 5. And so for that, we are going to first just note that the exponent is now not r but negative r, so we get that negative r is equal to our logarithm, and again it's log base 10, and we're going to be taking the log of 5. But I have this extra step because I need to get r on its own, so I'll divide both sides by -1, and that's going to give us r is equal to, and dividing anything by -1 is just going to give us the opposite of that quantity, so I'm going to get minus log 5. All right, and so go ahead and put that in, minus log 5, and we get about -0.699 if we round to the nearest thousandth, so -0.699 there would be our approximate solution. All right, and so then how about E? This is going to say that x is equal to log of 0, and so what are we going to get here? Well, log 0, well, it's undefined. What's going on there? All right, so we said here this is undefined. And so our conclusion ultimately here, if this is undefined, would be no solution. Why is it undefined? Well, can I raise 10 to some number and get 0 out as a result? And the answer, according to what we're seeing here with the logarithm, is no, we can't. Now if you go back to the sections on exponential functions, right? 10 to the x, it's going to look like this. And if I raise 10 to a large negative exponent, say like 10 to the minus 10th, okay, that's going to give me a really, really, really small number. So in other words, as I move way out to the left, okay, my graph is going to approach the x-axis from above, right? But I'm never actually going to hit 0. That's the point. 10 raised to, say, negative 10 million, right? It's going to be a really, really small number, infinitely small, but it will not actually equal 0. And so this equation actually has no solution. All right, and then here, for the last one, we have 10 to the x is equal to negative 2. And so that would give us x is equal to log of negative 2. And so let's go to the calculator. Log of negative 2. Also undefined. So this equation also doesn't have any solutions. And why is that? Well, now we're saying, can I raise 10 to some number and get out a negative 2? According to the log, well, the answer there is no. And it goes back to this exact same thing, right? If I raise 10 to any power, whether it's a positive number or a negative number, I cannot get a negative output from that operation there. So in fact, this has no solution. And more generally, let's make a little comment here. Okay, log base b, okay, of anything. Okay, this is only defined when the thing inside the log, whatever we feed the logarithm, is positive. Like we're seeing here, if I try to take the log of 0 or the log of negative 2, I'm going to run into problems. And it has to do with the fact that for exponential functions, okay, their values cannot come out to be negative. Okay, so this is a consequence of that. All right, that's going to do it for this problem.